Let's now enter the fourth chapter of this MOOC, which is also the first hands-on on the NanoEdge AI Studio. So regarding the MOOC timeline, we will now present the NanoEdge AI Studio import from SDCard feature. Regarding the general workflow of the NanoEdge AI Studio, we will focus first on collecting the data using the dedicated application provided by the NanoEdge AI Studio for the STEval STWin KT1B board, and importing this collected data using the dedicated import mode, which is the import from SDCard import mode. The prerequisites for this section are quite limited since you only need the NanoEdge AI Studio version 3.0.1 or higher, since the data logger feature only appeared in the 3.0 version. You need also an STEval STWin KT1B board and a blank micro SD card. The advantages are that this feature allows fast prototyping with no effort spent on the logging application, since it's provided as binary by the tool itself, and it supports all the embedded sensor of the STEval STWin KT1B board, including the industrial class accelerometer that we will use in this MOOC, but many others that are listed in the reference manual. The limitations of this approach is that the logged data is not human readable until it is imported in the NanoEdge AI Studio. And of course, it only works with the STEval STWin KT1B board. So logging itself will go in 3 steps. In the first step, we will program the STEval STWin KT1B board with a flexible and generic application. Then we will select the sensor that we want to use, accelerometer 1, and generate a .json file that we will put on an SD card. And the SD card will then be inserted in the board, and the board, the application that has been flashed to the board, will read this JSON file and program accordingly the sensor. The second step will be to do the actual data logging, and the final step will be to import from the SD card that will be filled during the data logging in the NanoEdge AI Studio tool. So the very first step will be to check that the input micro SD card is empty. So I will use SD card reader, so an USB one, and indeed it's empty. So I can remove it from my PC and insert it at the bottom of the STWin KT1B card, like this. Then I will have my 2 USB cables. So the first one will be put on the debug link, connecting the ST link, and the second one on the power supply. So you can see that the board has been detected and the default program is already running, but we will replace it. So the first step will be to launch the NanoEdge AI Studio tool. So let's go in the data logger option. The program is automatically checking if an STEval board is connected or not, and connect to it. Then we can directly load the binary. So this binary code will only be an application capable of do some data logging on a SD card, but reading which sensor it will get the input from a separate file. So first we load this binary on the board. So the board is being programmed. And then we have to select the sensor we want to use. To do so, we will need to go to the Configure Data Logger tab, but first we will reconnect the SD card to the computer. So I will power off the board and also power off the ST link to avoid any issues. Take the SD card and plug it to the PC. So it's now available. So in the data logger, we can see the list of all the available sensors and some configuration. We will enable the first one, which is the accelerometers we want to use. set the full speed to 8 and the output data rate to the default value. These values, these configurations are detailed in the datasheet of the board. We will not review them at the moment and use this value instead. So we will download the configuration for this sensor as a JSON file. So I will put it on the right letter, so it's F, and just put it on the root level of the kernel. So I can see now that I have my JSON file. Let's disconnect the card and put it back in the board. And power up. Let's have a closer look to the board. We can see now that we have an orange LED that is blinking quite slowly and a red one that is blinking fast. So the tool describes what is happening. So when we plug the board with the application loaded on it, if the SDCard is not inserted properly, the orange LED will blink fast, which is not the case here. If a JSON file configuration is present in the root folder of the SDCard, the custom sensor configuration will be loaded from the file itself. So for the moment, the board is waiting for us to press the user button, which is located here. And as soon as we will press it, it will start doing the data logging. So you can see now that the orange LED has ended blinking, but instead a green one is blinking, which means that the data is being logged from the accelerometer. Let's stop this data logging. So we are back in waiting status. So now we need to retrieve this data logging and import it in the NanoEdge AI Studio. So for that, I will unplug again the board, as well as the ST-Link, and extract the SD card, put it back in my SD card reader on my PC. So on the SD card reader, we can see that there is still, of course, the JSON file, but there is also an extra folder containing a big .date file containing all the data that have been captured. To import this .date file in the NanoEdge AI Studio, I will create a new anomaly detection project. For example, I could create also one class or an N class project. Note that for the extrapolation, it's a bit different regarding data logging, as we already saw in the theoretical part. So let's take this project. So it's a ST-Eval ST-Win KT1B board, 3-axis accelerometer. Let's keep this RAM. We do not care since we will only focus on the signal acquisition. So let's add a signal and select the from datalogger.date file. So the SD directory is my F drive. So I just select the folder that contains the .date file. Since it contains several files, there will be one folder created per JSON file. So if I do several logging with the same JSON file, they will be put in the same folder. I have to set my signal length, so I will put, for example, 256, and click on continue. So this sensor has been selected, that is being found in the file. This is my buffer size, 256. So the tool is parsing the file for the data and will show what it found. So we can see here, so we have 768 values per line because we have 3 times 256 because it's a 3-axis sensor, and we can import So of course, the bigger the file, the longer the process can be for the import. The best also is to copy the folder from the SD card to your local drive, because the speed of the SD card can vary among the SD card. And so we have now our input signals. So that's it for this chapter. The same way we could import the abnormal signals by, for example, shaking the board like this during the acquisition, saying that this is abnormal behavior of the system. And then we could run a benchmark and deploy a vibration detection on this board. This is the end of this chapter. In the next chapter, we will see how to create your own data logger in order to use the two other options that are available in the NanoEdge AI Studio tool to import data.